Welcome to the Maintainable Software Podcast, where we explore the art of improving existing software with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined from sunny California by Andrew Watkins, who is the VP of Engineering at Buildops. Andrew Watkins, we're so glad to have you join us on Maintainable. Welcome.
Hey, thank you for having me.
So as you reflect on your time in the industry, what do you believe are a few common characteristics of, dare I say, well-maintained software?
Some good characteristics of well-maintained software would be encapsulation, being able to test your code, be able to decompose your code such that it can be modularized, and as aforementioned, easily testable. They kind of go hand in hand. Being able to wrap your code around a particular domain and keep it as much as possible single use, single area of responsibility.
I've had a number of people on the show talk about single area of responsibility. Could you, for those that might not be that familiar with it, can you kind of give a high level overview of what you mean by that?
Yeah. So say you have a particular method or module or whatnot, making sure that it is programmed and architected such that it only does one singular function and only that. It doesn't try to do too much. That's kind of a broad stroke. It's a little bit high level, but imagine a method that's adding, it's an addition function, right? Well, that's all it does is it adds. It doesn't try to add plus multiply. It doesn't try to add and subtract. It just adds. That's what you kind of want. When you get into real world problems, oftentimes as you work with your product team or you're programming it for yourself, you're like, oh, I'm going to have this method that's going to call this API, pull back some information, and then I'm going to process it, right? And as part of that processing, I might try to do too much. I might try to do that addition, do some subtraction, do some computation that is outside the bounds of really maybe just calling that API and returning some result in a transform state.
Kind of expanding on that, let's say you call something that's supposed to give you a total price. I'm trying to think of dig into that. So if you have adding and subtracting and you're like, okay, what's the price for this? Or maybe it's the total price for, let's say, an invoice or something. Are you advocating that you should be able to call one thing and then that goes off and calls multiple things itself, or that you're actually calling all the individual steps initially?
Not calling all the individual steps initially, but it's decomposed such that you can call, so say you're pulling something that's getting a price, and then particularly you're taking that, that price and that invoice, and then applying it to, or applying a receipt alongside it, against that particular invoice, right? What you probably want to do is instead of combining both of those into one operation and then delivering the result, you might want to, call the invoice, get that particular total amount separately, call the receipt, get that total amount, and then have another method that then actually does the computation of figuring out your computation after the fact. So each of those can be tested individually. It's a little bit more work. You could combine them all into one, but then if one particular piece of that fails, the whole operation fails. Whereas maybe we've done this in the past, especially with ETL pipelines, you might want to be able to, if you get the invoice, cool, you can store that. If it fails on getting the receipt, that's bad, but you can still recover and you don't have to call the invoice again. You can just call that receipt and retry against that and then be able to pull the result. Just makes it more scalable, more testable, especially when you start chaining operations together. In this particular example, say you had 5 invoices you're doing. If you're pulling all the invoices at once and one of them fails, then the whole operation is kind of blown up. So,
and you said easily testable. Can you kind of help explain that a little bit as well? I think I've had a number of people talk about that as well, and I speak with engineers that are struggling to really know what that means sometimes, and they're like, well, what types of tests, or are there some paradigms that testing to someone that's never done a lot of testing themselves seems hard in the first place to them? And so I think there's that kind of that next step of okay, once you're kind of familiar with writing certain types of tests, we talk about writing code in a way that makes it easy to test. Or how testable will this be? How do you kind of start that process of thinking through that model?
Fantastic. Yeah. Actually, here's another real world scenario that we ran into, and it's going back to this invoicing example. So as part of one of our processes that we recently integrated, we integrated with third-party accounting software like QuickBooks and Sage and Intact. And we utilize a third party to do this, but a fair amount of it's just API driven. We have a queue. When an invoice is updated, when we receive receipts, when we receive payments, an item goes onto the queue that is then going to trigger the integration into the third-party software like QuickBooks or whatnot. And so we have, some code that picks it up off the queue, does various transformations, pulls in more data, and then posts it out and deals with error requests, right? So going back to testability, when it was originally written, the developer kind of thought of this as like, okay, I'm going to pick it off the queue, do all these transformations, post, receive responses, post back, right? And I was like, that's great, fantastic. He wrote beautiful code. However, I'm like, okay, now me, the second developer that's coming in, how do I run this? How do I test this? How do I do it? How do I run through this process? And he's like, well, cool. You have to put an item on the queue, and you have to also have the ability to, as part of the enrichment process of my code, you have to have the ability to call like our database, certain APIs, and have the whole infrastructure set up to be able to test my code, And I'm like, that's awesome. I don't want to do that, right? And so that's why I started going into look, we should probably start decomposing particular parts of this code such that either we can mock it, whether it's a third-party API, or I can stub it out, say the inputs that are coming from the queue, so that I can easily identify problems within each part of the code without having to go and set up the whole entire chain to make a change to this particular type of code. And so I use that as a kind of a model when I explain like how granular do you get to test. Like as you build your functionality, if you think about testing at the upfront, you might say, okay, I know I'm going to be getting these payloads from the queue. So why don't I just, instead of having a queue there, take those payloads and just dump them into my test directory, because they're just JSON basically. We're using SQS, and Lambda's on the tail end of that, so it's just picking up as a handler. Cool. I can use that to test that, and then it's going to have certain outputs. Then I can just take those outputs and say, okay, I'm going to put that to my transformation logic, and those methods that do that are going to take those are the inputs, and they're going to dump them to an API. And then I can just mock the API's request and response, and then have well-tested code that, it's not testing, 100% test coverage, like the very granular unit test, but it's testing the overall functionality, and it's very easy to follow. If I need to make a change to that transformation logic, I don't need the SQS. I just have the output of whatever was picking up off the SQS to be able to do it. I've for my development team, I've tried to use that as a best practices for like, look, you don't need to test everything, but test what you're trying to actually build. You don't have to do it beforehand. I actually don't do like complete test-driven development where I write my tests first. But as I'm building, I'm like, okay, how am I going to test this? How am I going to provide the inputs and provide the outputs such that I can have someone else run right behind me and be able to easily pick it up.
Do you use the terminology technical debt often in your day-to-day work?
All the time. We are in a very good state now. But previously, our system was very reliant on our infrastructure. Namely, we're an AWS shop, and we used a fair amount of AWS utilities that were only available within the cloud. Their local development was extremely difficult when I first arrived. And since then, we've actually backed out of that and removed a lot of that functionality. And I would classify that easily as technical debt. In making a better developer experience, we've been gradually chipping away at either removing those components that were tightly coupled to AWS and making it such that, hey, we can develop locally, we can deploy locally, and also we can easily deploy through our CD right back to AWS. In doing so, our coding standards against what we had built, again, tightly coupled us to like certain components of AWS that they offered. And so we've had to remove those. A particular example about that would be we use Lambdas, much like a lot of the modern world. However, our Lambdas were very, very tightly coupled to something called AppSync, which is like a managed GraphQL service. And they had domain knowledge against AppSync, which again kind of breaks the paradigm. The Lambda should just be encapsulated to do whatever it needs to do. It shouldn't worry about what's delivering it or what it needs to call back into.
And so with that, those types of examples of technical debt, your team's trying to improve their day-to-day development experience and workflow. Are you finding that there's this allure with a lot of these cloud-based tools to go down these paths to integrate because they'll save you time and get things up and running quicker? Or do you feel like they tend to, like, it's more of a scenario where I don't know if you were around when the decision to use those technologies were initially or not, but what's the take on like, did those give you some certain types of trade-offs early on that you later be like, okay, now this is becoming more of a challenge, but it served its purpose for then, but it's not going to serve our purpose going forward? Or do you feel like it was sometimes maybe the wrong decision in the first place? How do you distinguish that?
Yeah, so in this particular case, it was definitely the allure of new technology, and I wasn't around for that, to be honest. That kind of drove the decision. For me, I'm much more pragmatic. One culture that I've tried to build within Buildops is more of a DevOps based culture. It's like, cool, we can code. We're the best coders in the world, just like everyone else. However, how do you actually deploy your code? How does your code make its way through our different environments and get into production? How easy is it to build up a new environment to be able to support your code? Some of the decisions that were made earlier on that didn't really take that into account. They were just like, oh, shiny new object, let's go use it. We'll figure it out. And so we'll make decisions on our code based on that object. Whereas for me, it's more kind of the reverse, where it's like, okay, I have my wonderful code. Now I got to think about how is it going to move out into production. And for me, that is way more interesting and also like a good problem to solve, but also lead to some very good best practices about making sure that you're decoupled from your actual environment, but then making sure that the environment is part of your consideration for when you are building your application. So now we just use plain Docker on ECS containers with like Fargate, which itself is relatively newish, but works really well. So
Do your developers work like on their local machines and able to perform most of the type of work that you would be able to run in production as well? Or is there still quite a big difference between those environments of like, well, they can work on certain pieces of it, but they can't really do like an end-to-end full experience in a local capacity? How does that kind of approach? I say that as someone coming from like the Ruby on Rails world, where it's like you spin up everything locally and you eventually figure out how to push it out. And I feel like it's always been really good at the local environment side of things, but I've always been curious how that works in other technology stacks.
Oh, I can go into depth on this. So we're almost at the 80-20 rule on this. So the developers can do about 80% of their development now locally, which when I first came on was 0%. So I feel very, very good about that. Where it starts to fall down is that coupling between some of our Lambdas and some of the other Lambdas that we have kind of a chaining of Lambdas that talk to each other. And so you can get so far with being able to run those locally. But then after a couple hops, then it starts to fall down. It becomes a lot harder. So that last 20% becomes very disadvantageous. So for the most part, it still kind of works, But if you do have to develop in those tail end Lambdas, then you actually have to go into our dev environment, and we have a process as we just use process on top of our development practice to say, hey, team, I'm taking over the development. In our development of those Lambdas, you might see some peculiarities and making some changes. I've tested those because Lambda, again, just takes some inputs and does some, spits out some output. So be aware. But yes, I also, come from the Ruby on Rails world where you run everything locally. And there are cases where you can run Lambdas locally, especially with the serverless framework. They have offline mode. But the way we coupled our Lambdas together kind of stopped that from being a useful pattern, which was, unfortunate.
So like that was like I think some good examples of types of technical debt that your team has needed to kind of like work through over time. And how do you, for other things that pop up that are like maybe a lower priority seemingly at the moment, how do you and your team go about organizing that work, prioritizing it, and deciding when or if it'll ever get tackled? Like, what's that process look like?
Every week, I hold a meeting where I bring a fair amount of the developers in, and we kind of discuss architecture and coding and whatnot. And I really want to know, and we run on a normal 2-week sprint cycle. So having this meeting every week should capture a lot of the information that's going out for what we're developing, both for the current sprint and the next sprint. And I make it a point to bring up like, hey, what are we developing? I want to know about it. I want documentation on Confluence of what architectural decisions are we making, whether it's small, like a database change, or whether it's large, like we're introducing a queue and Kafka and whatever else, that might be impacting our system. And during that meeting, I expect people to raise their voice and saying, hey, I am programming it like this, given this particular trade-off. Like I have, the end of the sprint's coming. We need to release this to production, right afterwards. I'm not going to have time in a hypothetical example, to add security to my API endpoint, right? And I'll be like, okay, thank you for letting me know. That's either not good. I will go to the business and say, we cannot release this on Monday because we don't have security, and we can't. If we are hacked, that is, it's the end of the business. So I will fight that fight. Versus, hey, it's something lower. The queue that we're using, it's a FIFO queue. We don't need that. It should just be a standard queue or whatnot. But we can switch it off and change it at a later time. And so then I'll make a judgment, or ask, if I don't have enough knowledge, or somebody does, be like, look, what do we think we should do on this particular case? So then we document it and put it onto Confluence, and then create an ordered list that we keep track of. And I don't like to throw it into Jira because I feel it gets lost there, to be honest. And so I have a page of effectively high level tech debt, and then another page that's more like low level tech debt, like things that we need to address. We can just skim through it and be like, okay, is this important? Are we getting rid of it? Do we have a better way? And then we'll eventually take a look at it. We've been really busy over the past several months in terms of features and functionality and bringing clients on board. During the summer, we're looking to have a little bit of downtime. So that's why I plan to start, addressing some of these lower level things that, are annoyances more than anything else. So
I know I've talked to a couple of people around how they try to plan for what they call slack time, or lots of different things where it's just more of we're going to have a period of time to come back in, kind of take care of a bunch of this at the same time, which would be great. Get as much done as we can and get tidy up before we, start moving on to the next sprint. It's like sprint, but when do you stop to catch your breath for a little bit, So I know there's systems out there where there's been decisions made by the team or stakeholders or a manager somewhere to say, okay, that doesn't seem important enough for us to deal with, maybe right now. Kind of it's kind of air quoting that a little bit. It's not bad enough or painful enough to deal with. But as you bring new people in, they might bring that back up again and be like, hey, hadn't we done that? How do you go about capturing those types of decisions and referring back to that information, or so that someone was, do you expect people to know that, or just have well, we already decided that 2 years ago, we're not dealing with that? Is that ever persisted in a way that you found in in a manager role where you find yourself being well, you might have said no then, but it doesn't mean no forever. But then the developers kind of translate that, oh, that's just never going to get taken care of. And so they stop asking about it.
Yeah. So I do keep that Confluence document. So when they come in, you can reference it. And be like, oh, yep, we thought about that. That's when we did, because it has a date on it. And if the developer feels, hey, I actually do feel this is more important for X, Y reason, they can talk to me, or, during that meeting that I have, they can bring it up and be like, look, I really do think this is important. And I'm more than, if they say, okay, I'm like, okay, let's work with the business to figure out during our sprint that, well, first we got to estimate it, and that's very important for me, because nothing worse than going down a rabbit hole. But, we can figure out hey, time box this to, let's say, 3 days or whatever you need, but it has to be time boxed. Let the business know, or me, your squad leader, such that it can be put into the sprint. You have my backing that this is important. It needs to be done as part of the sprint, as opposed to some other, feature. And I'll make that determination and against our priorities, since I'm aware of them. And go ahead, have at it. But remember that time box, because what I don't want is, let's take, our build times are too long. You can probably shave a good 3 minutes off of that. And then depending on how OCD you are, you might be able to get down to 2 minutes. But that extra time, might take an extra week. And it's the justification for that, I won't be able to, to explain to the business, but I will be able to explain a certain amount of time, and what it'll save.
We'll be back with our interview with Andrew in just a moment. Hi, it's me, Robby. I wanted to take a quick moment just to say thank you for making time to listen to the Maintainable Software Podcast. If you're finding these conversations valuable, please consider sharing a link amongst your peers and/or writing a review on Apple Podcasts. Also, do you know someone in the industry that I should be speaking with on Maintainable? Shoot me an email to robby@maintainable.fm. And now, let's get back to our interview with Andrew Watkins. In an ideal world, how often do you believe your team should be focused on, say, improving existing code versus producing new code?
So I have a firm rule on this. If you see broken code and you're touching broken code, fix broken code. Now, you have to be pragmatic about this and let me know, or your squad leader know. If you see it and you're like, look, by pulling on this thread, it's going to unravel a lot and I'm going to have to rewrite it. And, the dreaded rewrite, and it's going to take 4 months. I'm going to say no. But I want to be aware of it so I can put on my little board and then we can think about addressing it at some, time in the future. However, if you see something that's like, yep, that code's bad, I'm going to need some extra story points, maybe another day, as I'm doing this feature to just refactor that, put some tests around it, and we'll be good. I will totally support that and will absolutely have your backing if anyone talks to me because we want to clean up our code base. We want to make it better for the next person. And if we just keep shoving it under the rug, that's never going to happen. And it's every developer's responsibility to identify and then be able to do that. Because what I found in my experience is when you let something fester like that for too long, that code inevitably comes back to haunt you at the worst possible time. And you're like, yep, I saw that. I should have fixed it. And now our integrations are like broken. And we are going to now have to spend that 4 months to fix them, So
I'm curious also, sounds like because you've mentioned working in sprints, is your team broken up in a way that like if things get shipped, bug fixes that might be popping up, are those part of the sprint, or do you have like a team that's kind of being more in a more reactive state type of work that they're in? And how do you approach that? Is there like a rotation to that, or is everybody kind of involved in producing new features, updates, things that are getting shipped in the sprints versus just reacting to the day-to-day things that pop up?
Cool. So currently, because we're an early stage startup and my team is relatively small, we're about 22 engineers right now. And we're broken out into different squads as we call them P0s, which isn't totally true. As items come up that require hot fixes required by the business to be taken care of, like in 24 to 48-hour time frame, we look at the area of the domain that it's focused on, and then apply that to that particular squad, who will then triage and take care of it. And then I'll help out as well as needed if I know the squad is slammed, or I'll find another resource if absolutely necessary, but I don't like to do that. That is what we do now. Eventually, I want to move to a model, and it'll be a progression where there'll be somebody who will be on technical debt for that particular sprint, as well as those bug fixes, that'll be coming up for that particular squad. And that'll be a rotating thing from sprint to sprint. And then as we grow larger, knock on wood, then we will get to, your traditional enterprise like L1, L2, L3 support. So we already have, and the nice thing is even for a fair amount of our integrations, I'm very much documentation based. So we put together runbooks basically for me and other developers. So if one developer has been working on integrations and our syncing is failing, they say, hey, document why it's failing, make a judgment call on whether you're ever going to see this again or whether it's a common use case scenario. Put it onto Confluence such that if you're not around, someone else on your team can pick it up, or I can pick it up, so that we have coverage.
You mentioned run books there, and had a few different guests mention those. And I'm curious, can you how detailed do you get in your typical run books? Do you do it for this type of specific problem? This is the way you kind of go about debugging it. It's get pretty granular. Do you use screenshots, videos at all, or any sort of narration? How do you go about doing that to make it easy and quick to for the person that's going to be hopefully leaning on that documentation or material to quickly digest it, I suppose?
Yeah. So I prefer just text-based approach. Some of the other developers actually prefer putting on videos, and so they do. That's on them. I never watch them. No matter what, I want them to put together text and the steps necessary to both reproduce and to be able to troubleshoot. And I ask them to go as granular as possible. Now, having said that, we've actually given it to our customer experience team. These are the people who are not technical. Well, I take that back. They are somewhat technical, but they're not programmers. And they work hand in hand with our clients. And they've been able to pick up what our programmers are putting down and actually run with it, especially for some of our adapters that are sitting on client machines. They'll be like, okay, I understand this sync is not happening. Let's look at these particular logs. Oh, I'm seeing this. Okay, I know what to do in our software, even being able to log into AWS and potentially reset a queue to allow other entries to then start flowing through, maybe after resetting something on the device. I was actually pretty impressed. So
I think that's an often overlooked benefit of documentation and making it simple enough. And then do you go through, like once someone produces the run book, like have someone go through and test that they can kind of go through it right away? Or is that something you just find out the next time that pops up and you're like, to see how comprehensive it is?
I don't do like pull requests on top of it after it's been written, but I do tell other developers, and this has actually worked pretty well. If you don't, and this has also worked actually extremely well for onboarding as well. If you find something lacking in the runbook or in any onboarding material, it's up to you to add it. So for the next person, and it's fine to be more. Don't delete stuff, but just add to it.
So outside of like say writing clean code and good documentation and tests, are there other characteristics that you're asking your team to strive for and to think about as they're approaching their day-to-day work?
One thing is thinking about how to modularize our code, right? In the rush to deliver new features and functionality, sometimes it's very easy to slip into habits where it's like, okay, I'm just going to write this method and it's it'll work, it'll do what it's supposed to, but then really taking an onus on saying, okay, going back to that addition method, which is really kind of silly, but I'm writing this addition method. Maybe I can reuse this in other different areas of the code and putting it into utilities folder or whatnot, and then heavily documenting it. And then when you're going through other developers' pull requests, making sure that you let them know about this, that it is there, that they should be able to use. And then a lot of it is actually good code hygiene. I have a very strong, preference. I wouldn't say it's a rule on this, but depending on your language, try to keep your methods under, 20 lines of code, 10 ideally. If you're going over, you're probably doing it wrong, Look out for that with other developers as well. And that kind of forces a habit of encapsulation, because then it actually thinks about like, okay, why do I have this 100-line method? What is it doing so much that it needs to have that much, Being able to think about the overarching picture of what we're building. I feel that's really important. So I'm a very big advocate of domain-driven design. And one of the tenets of that is coming up with a ubiquitous language to speak, when you talk to a product person, when you talk to our implementation team, when you talk to other developers. And that's just saying like, hey, we're calling this snafu widget, and we need to come to a common language around what a snafu widget is so that we don't have miscommunication between product, customers, development, Be mindful of that, because that's going to end up making you a subject matter expert on our product, but also within the code as well. So
I like that. And, it's interesting. We're talking around, just play it like this idea that sometimes when you're working on something for a very specific feature and you're like, well, and you just mentioned also trying to think about how you could modularize this, maybe it could be reused. And so do you think it's in that, when that happens, do you think things can tend to then deviate a little bit from the domain language, the ubiquitous language that you're using about the specific feature thing? Because like, well, this is actually, we could create this kind of more generic reusable thing that this time is just happens to be this. And so you end up with these kind of funny, weird names that only the developers understand, that currently only have the use case of being used for this one specific product widget that the product teams have been very, very clear about what it's called, but then you might end up naming it something more generic.
Yeah, that happens a fair amount. And actually I feel that's where programming becomes more of an art rather than a science, because, when you create, a generic module that's going to be used by snafu widget, right? You're effectively creating an abstraction layer, on top of it, which is good. But then you can take it too far and create too many abstraction layers. And then your code is very hard to follow. And it's like, well, this can be used for snafu widget, but it can also be used for something totally unrelated, like, foobar or whatever, And it's like, well, great. Why did we do that? So, and that's where the kind of art, and the pragmatism comes behind of being able to say like, look, I'm making this thing that can be used in multiple places, and it maybe should be. Maybe it's like a date picker or a calendar picker. But when you're going into like, say, integrations, hey, maybe this can be used between like QuickBooks, Intacct, Sage, whatnot. But maybe this is very specific to QuickBooks. So let's keep it to QuickBooks. And that's where the pragmatism comes in, right?
Do you find yourself more often on team rewrite or team refactor?
Team refactor. 9 times out of 10.
When do you think it's appropriate to really advocate for a rewrite then? Maybe that 10% of the time?
Okay. Rewrites are really tough because first, it depends on the level of code that was written to achieve what the business wanted at that particular time. And there's a lot of factors that could go into making that code that is no longer usable, right? And it's really coming up with the determination is, can we actually fix this code to do what we want it to do? Or is fixing it, because the code is so brittle, that trying to refactor it or take out chunks is just going to break the whole entire infrastructure like a house of cards? If that's going to happen, then you really do need to go into the rewrite, scenario. Most of the time I found when people first look at the problem, that's the initial gut reaction. It's like, well, let's just rewrite it, right? Because you don't have full scope of what the code's doing. But once you kind of get into it and, taking a step back, taking some time, really analyzing it, hopefully looking at whatever tests are there, you might see, oh, we can actually break this apart into chunks. And, then we can refactor as needed. But refactoring oftentimes leads to smaller risk footprints, meaning that you can, refactor bits and pieces as you go along without breaking the whole entire product. Which makes it more digestible for the business, as well as more digestible for testing and like programmer sanity. Because rewrites often tend, in my experience, to be like, okay, we're going to rewrite this whole thing. It'll take a year. And that year is obviously not true. It's probably going to actually be 2 years when you go through it. But there's that light at the tunnel is so far away, Whereas with a refactor, it's like, okay, we'll spend a month doing this little part, Once we're done with that little part, that's great. Now we're only 5% of the way there. We have 95%, but at least we've made progress. And you can kind of start tracking that progress as you go along.
Hi there. Do you know someone who might be looking for assistance with their Ruby on Rails application? Planet Argon would love to meet them. We're offering a $1,000 referral bonus. Send someone our way, and if they sign up for services with Planet Argon, we'll give them a $1,000 discount. And in return, you'll get a check for $1,000 in the mail, just for knowing the right person. Hop on over to planetargon.com/referrals for more information and to refer someone our way. That's planetargon.com/referrals. Thanks.
Yeah, what do you think that it's something that engineers, they have to kind of experience the pain of a rewrite to kind of become fans of refactoring and that kind of, or see the benefits of like, okay, well, now I understand why this is, because I feel like there's this interesting thing in the career arc for a lot of, at least in my experience with people that I've worked with over the years or have talked with, there's kind of like this point in their career where they feel pretty confident, and then they're like looking back and they're able to be like, if we could just use this other technology that I have, that I'm really interested in using, things will be so much better. Grass is going to be greener. We won't have all these problems, all this baggage that this platform has that I'm currently dealing with. It's going to be free of all of those. Obviously, we know that there's likely going to be a completely different list of pain points and things that you have yet to experience until you find yourself in that, even if you were successful with the rewrite. But how do you help those who haven't gone through that process kind of learn from your experience or from others' experience, when I think we often as humans kind of just rely on our own experiences to help inform these types of things?
Yeah, whenever a developer comes to me and wants to do a rewrite for X, Y, and Z, the first thing I really ask them is, well, why? What are we gaining from it? Because that's going to be time and money that's going to be invested in this, and I want to make sure that the outcome that is achieved is greater than that time and money that is put forth to do it. And I will want a very strong explanation on why to do it, but then it causes the developer to sit down and think, right? So moving languages, right? That's a really bad one for me. Or moving frameworks even, because I'm like, well, unless the framework, unless we wrote this in Perl, what was so bad about this language that, this caused it to do it. Now, if it's performance related, you're like, yeah, we, wrote it in like the 1.9 series of Ruby, and it's, now we need to write it in Go because this is doing stock trading. Okay, that's a good, it's a good use case, right? But I would really want a justification of like, why was it so bad in that particular language or that particular infrastructure or framework that doesn't allow us to move forward? If it is scalability, that's a very good argument that I can get behind. If it's code readability or just no documentation, no one understands what it's doing, it's a black box. Okay, that is a very good argument that maybe we can get behind. But I really want to force the developer to kind of say, why are we going to be doing this? What is the end result and what do we hope to achieve from it before we go and do it? And there are cases like one we did was because the old code was so buggy that every patch we did caused another regression within the code. Okay, then that's a good argument for doing this because we're just basically playing whack-a-mole within our own code, and it's where no one wants to be. So then you can come into time and cost to be able to do it versus just the endless amount of bugs that are going to be coming through this. But I want the user to understand the programmer to understand this before they just blindly go forward with it. So
nice. I'm curious if your team brings on junior developers at all.
We've brought in some developers that have come from boot camps. We've brought in developers that are right out of college.
Has that been something that your team had been doing for a while, or is it something that's kind of more of something you've been learning how to as a team to navigate and to help streamline the onboarding and the mentorship model that would require?
We had a junior team, I'd say. Well, I take that back. A more junior team, but our team was actually more offshore than anything else when I first started. We had some junior members. I'm a big fan of doing internship programs, bringing on junior developers, as long as they have the support structure to be able to lean on some of the more senior, mid-level and more senior developers so they don't get lost or don't learn bad practices or don't, so that we make it fulfilling for them, as well as us being able to mentor those developers to become better developers that will then be advantageous for our company. And that support structure needs to be there for it to be very effective, I feel.
When you bring in interns and you placed into the pods, just among them, are they participating pretty quickly? Like, what's the typical ramp up time that you find that they're needing when they're coming out of a boot camp or something like that?
Yeah, so they get put into a particular squad, and that is what they start producing after their first 2 weeks. Yeah, so I mean, we will start assigning them stories. Within the first 2 weeks, we don't expect them to obviously do very much, and depending on their area of focus, especially given the complexity of some of our architecture, we would, in an ideal world, they'd be committing same day as when they started, but we expect them to be performant, not at the same throughput as like a senior level developer, but as a developer. And one thing that we like to do is also to provide them like, hey, why don't you start on something small, like a bug fix or some technical debt, because we have it documented. So pick one of these items and take a look at it and see what you think about it. And not one of the more high level overarching, hey, we need to replace DynamoDB, but like, hey, maybe let's just increase that build time by a minute, see what your thoughts are on this and take a look. So, and then that serves two purposes. One is that they get adjusted to how to build our software, how to deploy to dev, QA, and whatnot. But it also allows them obviously time to grow a little bit, to see our team, work with other team members, to start becoming adjusted. So,
have you had any, for lack of a better phrase, pushback from senior members when they're feeling kind of at capacity? Like, why are we bringing in interns or junior people? I don't have enough time to finish the tasks that I already have, let alone I need to now be partially responsible for the success of some, up and coming software engineer. Have you had that kind of experience at all? Like, at least have those types of conversations at all?
Yes, I have. And it's definitely, I wouldn't have said been an issue, but it's definitely come up on several occasions where, I have my own sprint goals, we have our own performance, and I'm getting asked a lot of questions, and especially when, unfortunately, there are multiple junior members that are asking one person questions. So it's very easy. I have a very good response for it, I feel. One is like, look, this junior member of your team, the reason why you're mentoring them is because some of the work that you've been doing that personally I consider, is, taking time away from your work, that you might be having to do for support of this. Well, they're going to do it. So make sure that they're trained such that they can take that off of your plate. And the sooner that happens, the easier it's going to be for you, and it's going to ramp up. Like, say you're doing an integration, right? Well, if you can train them up to do an integration, then you don't have to do the integration. You just have to kind of oversee it, or if you still want to, that's fine, but we still have more integrations to do. So the more that they can provide, the more they can help. But if you're also getting, bombarded, tell them to come to me. I'm more than open to take questions, and I will redirect that person to somebody else who I feel would be appropriate for doing it. But also, they might be junior members. So something that might take that person, 30 minutes might take the junior member 4 hours, right? Especially as they ramp up. I'm okay with that 4 hours. Like, I might tell them, spend the 4 hours and go through it. Time box it at that. Don't take days, but once you get through that, I expect as you grow as a developer, you won't take 4 hours next time. You'll take 2 hours, and then, down to that 30-minute mark. So do that.
It's always this interesting thing where I think that we often forget as, software engineers, what it was like for ourselves to learn. We were just as junior as them at some point. We may or may not have very clear memory of what that experience was really like, whether or not we did have mentors or not, how much those people helped us, begrudgingly or not. It's always this interesting thing where I'm just like, one of the reasons I'm a big advocate for having interns and junior developers come into teams is because just to keep our team, one, we have to recruit people, right? That's just an important part of it. And we can't just always go off and find new senior level people. But the other part of it is like, we kind of owe it to the next generation of people to like help pass on the baton a little bit and share the things that we're learning. I've seen some senior level engineers struggle a little bit because they become very helpful for a while, but then they kind of get to this point where like, oh, maybe the junior developers or interns start to go to them most often because they're the ones that are most receptive to help them. And they're like, and so then they start worrying, like, maybe I was a little too accommodating and now they're always going to come to me because they're not going to other people because someone else that might have put up a little bit of I'm not available right now. So then they don't go back and ask that person again. And so I think it's an interesting dynamic for the team to try to figure out. And I think it's great that you were like, well, send them my way and then you can help reroute them or something. I think that could be quite helpful. Anyways, I just wanted to kind of talk out loud about that a little bit because I know there's people listening that are probably on either side of that being like, I don't want to bother people as a junior person. Like, I don't want to distract them. I don't want to, it's hard enough to come and ask you for help because I'm a little nervous. Like, I'm intimidated in some ways by like your knowledge or the fact that I know that you're busy. You've got things going on and I appreciate your time, but I need help. And I don't want to just, or are you expecting me to just already know how to do this? And I don't yet.
Yeah. And I emphasize, with my team, it's like, look, if you're spending more than an hour on a problem, please come talk to me. I might not have an answer, but I'm going to try to help you out, even if I am busy, because we're, remote, because of COVID. So it's like, ping me on Slack. I'll see your message. I'll probably respond just like, hey, I'll get to this. And I will, and then try to actually act as to unblock somebody or to go to, your manager and be like, hey, can you help him with this? Because I know how busy they are. So, but yeah, it's funny you mentioned about like remembering, back in the day when we were first starting out. And I remember my first, mentor. I won't call him a mentor because we're still really good friends and I want him to get a big head. But, some of the things that he taught me, especially as I was, starting to develop and totally developing the absolute wrong way, and how he kind of guided me towards like, hey, maybe you should think about this. Maybe you should think about this. And here's when you should ask questions, here's what you need to think about as you're becoming a better developer. It really touched me, and I still keep in good touch with him today. Now he asked me for questions, so I'm very happy about that.
That's great. Yeah, one of my mentors, I ended up after leaving that company and a couple years later starting Planet Argon, I was able to recruit him, and now he's my business partner. So now we ask each other completely different types of questions, and I think we both probably are mentors to each other now. But it's I often forget of just like how important he was at that era of my career as well. And so thanks, Gary. All right, with that, a couple quick last questions for you, Andrew. So is there a non-software, non-technical book that you find yourself most often recommending to people?
Interesting. Yes and no. I read a lot of sci-fi and fantasy, so I actually do get a fair amount of questions of, hey, what's a good book to read, And so, especially in that genre. One I love, it's a very morbid book, but it's a great author. It's one called Heroes Die. It's very much an anti-hero, sci-fi fantasy mix that I just really enjoy for some reason. Kind of goes along the story of a guy who comes from, it's a dystopian world. He comes from very low class, but he's an actor. And he's a great actor, but he's always considered low class on Earth. And how he just kind of like forges his own path, and, sometimes through brutal means. But I just really, really, really liked it.
Excellent. I'll include a link to that for everybody in the show notes. And where can listeners best follow your thoughts and ruminations about software engineering and development online?
So I don't have a blog. Really, I'm not very active on Twitter. However, Buildops will be starting a blog relatively soon. And so once we do, I can share that link, and we can, you can start seeing some postings there.
Well, excellent. Well, maybe one of your first blog posts could be a link to your episode on Maintainable.
There we go.
Well, with that, it's been such a delight having you join us on Maintainable, Andrew. Thank you so much for talking shop with us.
Yeah, thank you for having me.
Maintainable.